Hello everyone, in today's video we're going to cover trig ratios. After studying today's section, you should be able to use trig ratios to find missing side lengths and angle measures of right triangles. Now, what is trigonometry? So trig is the study of triangle measurement and how trig functions relate the angles of triangles with ratios of its side lengths. So we'll use trig to find angle measures as well as side lengths. Now, each acute angle of a right triangle has the following trig ratios. So the three trig ratios that we will look at are sine, cosine, and tangent. Sine, cosine, and tangent will tell me what the relationship of the sides are. So sine is the ratio of the leg that's opposite the angle to the hypotenuse. So if I want to find the sine of big A, which would be angle A, I look at the side that's opposite, so little a, over the hypotenuse, little c. So my ratio would be A over C. So if I wanted to find what angle A was, I would have sine of A is equal to little a over C. Now, if I wanted to find the sine of B or angle B, that's again the side opposite, so little b over little c, which is the hypotenuse, so B over C. Now, cosine is the ratio of the leg that's adjacent to the angle to the hypotenuse. So if I wanted to find the cosine of angle A, the side that's adjacent to angle A would be little b, because little c is the hypotenuse, so that side can't be adjacent. So my ratio of cosine A would be B over C, adjacent to the hypotenuse. And then if I wanted to find cosine of big B or angle B, it would be adjacent side, which is A over hypotenuse C, so A over C. And then lastly, we have tangent. Now, tangent is the ratio of the leg that's opposite the angle to the leg adjacent to the angle. So if I wanted to find the tan of angle A, it's the side that's opposite, which would be little a, over the adjacent side, which would be little b. So I'd have A over B. And then if I want to find the tangent of big B or angle B, again, it's the side that's opposite, so little b over the adjacent side, which would be A, so B over A. An easy way to remember these ratios is to remember the acronym SOHCAHTOA. So SOHCAHTOA stands for sine, cosine, and tangent. That's the S, the C, and the T. And then the O, the A, the H stand for opposite, hypotenuse, and adjacent. So sine is so because S would be sine, O would be opposite, and then H would be hypotenuse. So I know the ratio of sine is opposite over hypotenuse. Cosine is ca, which is adjacent over hypotenuse, because again, the ratio of cosine is adjacent over hypotenuse. And then tan or toa would be opposite over adjacent, because again, I know the ratio of tangent is the opposite side to the adjacent side. So by remembering SOHCAHTOA, I can remember these ratios easily. Taking a look at our sample problems, we want to give each trig ratio as a fraction in simplest form. So I have triangle ABC with side lengths 5, 12, 13. I just want to find these ratios. So I'm not finding any angle measures. I'm not finding any side lengths. We're just practicing finding the ratios. So if I remember my acronyms, SOHCAHTOA, these will help me find these ratios. So the first one is sine of A. So if I'm looking at angle A, I know opposite side over the hypotenuse, so 5 over 13 would be my ratio. Now, if I'm looking at sine of C, again, opposite over hypotenuse, opposite side is 12, hypotenuse is 13, so sine of C is 12 over 13. Now I'm looking at cosine of angle A. Cosine is ca, or adjacent side over the hypotenuse, so that's 12 over 13. And then cosine of C would be adjacent over hypotenuse. Adjacent side of C is 5, hypotenuse is 13, so the relationship of cosine C is 5, 13. And then tangent, TOA, opposite over adjacent. So the opposite side of A is 5, the adjacent side is 12. So my ratio here is 5/12. And then tan of C, opposite over adjacent, 12 over 5. Next, let's look at finding side lengths using trig. One thing we need to make sure that we do is put our calculator in degree mode, as if you have your calculator in radians, it will throw off your answers. Looking at number 4, we have a 28-degree angle measure, a side length of x, and a side length of 19. Now we'll relate all of our trig ratios based off the angle. So we want to find how the sides relate to the angle. Notice the 28 is the opposite angle of the side x, and 19 is the hypotenuse. So I have opposite over hypotenuse, which is sine. So here I'll have sine 28 is going to be equal to x over 19. Now think of sine 28 as just a value, it's a number. So now in order to get rid of this 19 and have x by itself, I would multiply both sides by 19. So 19 sine 28 is what x will equal. Now I can plug this into my calculator to get me what the actual side length is approximately. When I plug in 19 sine 28, I should get approximately 8.9. Now looking at number 5, I have 32 and x as side lengths and then an angle measure of 41. So again, I'm relating everything to this 41. 41 is opposite angle of side x and then adjacent angle of 32. Opposite over adjacent is tangent, so I'll have tan 41 is equal to x over 32. Again, I'll multiply by 32 to get rid of the 32 and have x by itself. So x is equal to 32 tan 41. When I plug in 32 tan 41, I'll get x is approximately 27.8. Now let's jump to number 9. So now I have 43 degrees, a side length of 36, and a side length of x. Again, I'm relating to the 43. 36 is the adjacent side, x is the hypotenuse. Adjacent over hypotenuse is cosine. So cosine 43 is going to be equal to 36 over x. Now the x is in the denominator, it's not in the numerator, but I'm still going to simplify this any way I would do any normal equation. So I'd multiply by x to clear that fraction. So this will go to just 36, and then I'll have x cosine 43. Again, I think of cosine 43 as any number, so I would just divide by cosine 43. So 36 divided by cosine 43 is what x will be equal to. So x equals 36 over cosine 43, and then 36 over cosine 43, when I plug that into my calculator, gives me a side length of 49.2. So x is 49.2. Next, we'll find angle measures using trig. Again, we want to make sure our calculator is in degree modes. So looking at number 1, we have x degree. I have a side length of 15 and a side length of 24. So here, again, I'm looking at the x degree. I know that I have the side that's opposite and the hypotenuse. Opposite over hypotenuse is sine. So sine of x is going to be equal to 15 over 24. Now I want the x alone, so I need to get rid of this sine. How to get rid of the sine is by using the inverse sine or inverse cosine or inverse tangent, depending on what trig ratio I have. So here I'd use sine inverse. So in order to find the degree, I'll always use the inverse. So sine inverse of 15 over 24 will be what x is equal to. So if I plug this into my calculator, sine inverse of 15 over 24 is 38.7 degrees. So x will equal 38.7 degrees. And then number 2, I have side lengths of 8 and 11, and then x degree. So using the x to relate my side lengths, I have the adjacent side, which is 8, and the hypotenuse, which is 11. Adjacent over hypotenuse is cosine. So cosine of x will equal 8 over 11. Again, here to get rid of cosine, I'll use cosine inverse. So cosine inverse of 8 over 11 would be equal to x. When I plug this in, x is going to be equal to 43.3 degrees. In today's lesson, we learned 3 trig ratios are sine, cosine, and tangent. I can remember the acronym SOHCAHTOA to help me remember the ratios of the sides. That's a wrap on today's video. We'll see you in the next one.